Welcome back. In this video, we're going to continue talking about transformations, and we're going to talk about when there's a coefficient multiplied on the outside and what that will do to the function. So kind of using our algebra notation, a times cosine, and this can be any trig function, sine, tangent, secant, cosecant, cx minus h plus k, or a times cosine, our new notation, just different variables, bx minus c plus d. So in the first video in this series, we talked about d. Now we're going to talk about what a does. So d is on the outside. D was a vertical shift. It's added on the outside, whereas a is multiplied on the outside. Multiplied lets me know it is a shrink or a stretch. And it could also be a flip. We'll talk about that too. And then outside lets me know that it is vertical. So the constant A represents a vertical stretch or shrink. It tells us if it will flip vertically, and it also helps us describe the amplitude. Now, the absolute value of A, right? So not the positive or negative, just the, considering the value of the number. That tells us about stretching and shrinking. The absolute value of A, that positive number, is the amplitude. So just looking at the absolute value versus, we'll talk about this third one, which doesn't have absolute value. If A is a number greater than 1, then that lets me know the graph is going to stretch vertically A units. However, if A is a value which is fractional between 0 and 1, so multiplying by 1/2 should make something smaller. That's a fraction between 0 and 1. It's going to shrink vertically by A units. And then lastly, if A is negative, so a negative A value. So before these two previous bullet points here, we were only considering the absolute value, right? So we're looking at how large A is. It doesn't matter whether or not it's positive or negative. But if A is negative, that is going to cause a reflection down over the x-axis. All right, so the A value tells us if it's stretching or shrinking vertically, as well as whether or not it is reflecting across an axis. So, for example, A, we're going to look at 1/2 times the cosine of x. So here's my standard cosine x graph. And we have 1, 2, 3, 4, 5 key points on cosine. So I'm going to list these a little bit different in this video. Cosine x, we have our key points. So we've got 5 points. We have 0, 1. We have pi over 2, 0. We have pi negative 1. 3 pi over 2, 0, and 2 pi positive 1. So looking at 1/2 cosine x, that's 1/2 times my output of cosine x. That's going to mean that my ordered pairs are going to shrink in the y by 1/2. So my ordered pair, instead of looking like a regular xy, it's going to be x and then 1/2 times y. So this 1/2 multiplied in there, that's going to cause the graph to shrink. It's going to shrink vertically, and it's going to shrink by a factor of 1/2. So notice I'm saying three things here. I'm saying what is happening, which direction, and how much. So my new key points for A, that would give me 0, 1 times 1/2 is 1/2. Pi over 2, 0 times 1/2 is still 0. -1 times 1/2 is -1/2. 3 pi over 2, 0 times 1/2 is 0. And 2 pi, the 1 times 1/2 is 1/2. So marking these points on my graph, they would look like this, and they create a graph that is smushed or shrunk vertically. It has less amplitude, and in fact, we'll go so far as to say the amplitude is 1/2. It's that positive A value, 1/2. So I'm going to erase this, and then let's look at example B. So for example B, we're going to say, okay, well, we're going to graph a cosine graph, but we've got this times multiple 3, or times -3 here on the outside. So it's multiplied, and it's on the outside. And again, multiplied on the outside lets me know it's a vertical shrink or stretch or flip. So what we know, since the absolute value of -3, since 3 is a number greater than 1, it is going to stretch vertically by a factor of 3. It's going to become 3 times as tall. And what the negative does is it makes it reflect over the x-axis. So we have a reflection here over the x-axis. What would that do to the ordered pair? Instead of having just xy, we have x, and we're going to take all of our y values and multiply them by -3. So my key points here for B, I have 0, 1 times -3 is -3. This point does not change. 0 times -3 is still 0. -1 times -3 gives me +3. That one doesn't change. And 2 pi, 1 times -3 is -3. So I'll plot these points. Let's see, we're at -0, +3, 0, and -3. So my cosine graph, it still looks like a cosine, but now it is flipped upside down because we've reflected across the x-axis, and we've also stretched vertically by a factor of 3. So 3 is my amplitude. We have an amplitude of 3 here. It's +3. We don't say a negative amplitude value. So I've listed my 5 new key points. I've sketched my graph. I've described my transformation. So in the previous video, we talked about a vertical shift. Now we've talked about a vertical shrink, stretch, or flip. So we've got 2 other topics to cover before we can combine them all together.